Welcome to aminacademy.com. In statistics and econometry, let us discuss about shape of frequency distribution, that is skewness and kurtosis. Frequency distribution can have two different shapes, symmetric or asymmetric distribution. Asymmetric distribution can be positively skewed and negatively skewed distribution. When the data values are evenly distributed about the mean, a distribution is said to be a symmetric distribution. Here, this is a symmetric distribution. These are asymmetric distribution. Now, let us discuss about skewness and kurtosis. There are two other comparable characteristics called skewness and kurtosis that help us to understand a distribution. First, we'll discuss skewness. Skewness means lack of symmetry. Here the symmetry, here it have skewness. Skewness means lack of symmetry, that is, we study skewness to have an idea about the shape of the curve drawn from the given data. When the data set is not a symmetrical distribution, it is called a skewed distribution, and such a distribution could either be positively skewed or negatively skewed. The concept of skewness will be clear from the following three diagrams showing a symmetrical distribution, positively skewed distribution, and negatively skewed distribution. You can see the symmetricity from the following diagram. First one, symmetrical distribution. Look at this curve. It's a symmetrical about the median. Exactly same in left and right. It is clear from the diagram below that in a symmetrical distribution, the value of mean, median, and mode coincide. Here, this line, all are having mean, median, and mode. The spread of the frequencies is the same on both sides of the center point of the curve. Next one, positively skewed distribution. In the positively skewed distribution, the value of the mean is maximum and that of the mode is the least. The median lies in between the two. In the positively skewed distribution, the frequencies are spread out over the greater range of values on the high value end of the curve, the right hand side. This is the right hand side. Then they are in the low value end. For a positively skewed distribution, mean is greater than median. Mean is greater than median. Median is greater than mode. Here, this is a positively skewed distribution. Next one, negatively skewed distribution. In a negatively skewed distribution, the value of the mode is maximum and that of mean least the median lies in between the two. In the negatively skewed distribution, the position is reversed. That is, excess tail is on the left side. This is the excess tail is on the left side. The mode is the highest. It should be noted that in a moderately symmetrical distribution, the interval between the mean and the median is approximately 1/3 of the interval between the mean and the mode. It is this relationship which provides a mean of measuring the degree of skewness. Some important measures of skewness. There are three coefficients of skewness that are called Pearson coefficient of skewness, Bowley's coefficient of skewness, and coefficient of skewness based on moments. First one, called Pearson coefficient of skewness, which is according to called Pearson, the absolute measure of skewness, that is equal to mean minus mode divided by standard deviation. Called Pearson coefficient of skewness is mean minus mode divided by standard deviation. Example, from the known data, that is mean is 7.35, mode is 8, and variance is 1.69. Then find the Colpearson coefficient of skewness. We know that Colpearson coefficient of skewness is mean minus mode divided by SD, and variance is given as 1.69. We know that standard deviation is square root of variance, that is SD equal to square root of 1.69 is 1.3. Now apply the values in formula. Colpearson coefficient is mean is 7.35, mode is 8, over SD is 1.3. So it gives minus 0.65 over 1.3 equal to minus 0.5. It is negative value. So it's a negative, that is this is a negative thing. So yeah, negatively skewed distribution. Actually, this distribution is negatively skewed distribution. Bowley's coefficients of skewness. In Colpearson method, the measuring of skewness, the whole of the series is needed. Professor Bowley has suggested a formula based on position of a quartiles. In symmetric distribution, quartiles will be equidistant from the median. That means Q2 minus Q1. Second quartile minus first quartile is equal to third quartile minus second quartile. That is Q2 minus Q1 is equal to Q3 minus Q2. But in skewed distribution, it may not happen. Hence, Bowley's coefficient of skewness is equal Q, by simplifying we get Q3 plus Q1 minus 2Q2 over Q3 minus Q1, which is equal Bowley's coefficient of skewness. Look at this example. If Q1 is 40, Q2 is 50, Q3 is 60, then Bowley's coefficient of skewness is Q3 plus Q1 minus 2Q2 over Q3 minus Q1. Therefore, applying the values 40 plus 60 minus 2 into 50. 100 minus 100 is 0 over 60 minus 40 is 20. 0 over 20 is 0. Therefore, the given distribution is symmetric because there is no coefficients values except 0. So, that means the given distribution is symmetric, you can understand. Next one, measure of skewness based on moments. The measure of skewness based on moments is denoted by beta 1 and is given by beta 1 is mu 3q square over mu 2 cube, where mu is the mean. Find beta 1, that is measure of skewness based on moments, beta 1 for the following data. Mu 1 is 0, mu 2 is 8.76, mu 3 is minus 2.91. So formula is beta 1 is equal to mu 3 square over mu 2 cube. So minus 2.91 whole square over 8.76 whole cube, which by simplification we get 0.0126. Next we will discuss about kurtosis. Kurtosis in Greek means bulginess. In statistics, kurtosis refers to degree of flatness or wickedness in the region above the mode of a frequency curve. Look at this, the here is continuous, it's bulging like here, this highest, it's bulging now, further it's bulged. One more time, kurtosis in a Greek means bulginess. In statistics, kurtosis refers to the degree of flatness or wickedness in the region about the mode of a frequency curve. The degree of kurtosis of the distribution is measured relative to the wickedness of normal curve. In other words, measure of kurtosis tells us the extent of which a distribution is more peaked or flat top than the normal curve. The following diagram illustrates the shape of three different curves mentioned below. Here, the first one, if a curve is more peaked than the normal curve, it is called lipocortic. This is lipocortic. In such a case, items are more closely bunched around the mode. On the other hand, if a curve is more flat topped than the normal curve, it is called platycortic. The platycortic. The bell-shaped normal curve itself is known as mesokurtic. This bell-shaped is a mesokurtic, that is green. We can find how much the frequency curve is flatter than the normal curve using measure of kurtosis. The use of kurtosis is we can find how much the frequency curve is flatter than the normal curve using measure of kurtosis. Measure of kurtosis, some formulas. The most important measure of kurtosis is the value of coefficient. It is defined as the coefficient of kurtosis, that is B2 equal mu4 over mu2 square. If beta equal to mu4 divided by mu2 square. For example, find the value of beta 2, that is measure of kurtosis of the following data: mu1 equal to 0, mu2 equal to 4, mu3 equal to 0, and mu4 equal to 37.6. Solution: beta 2 equal to mu4 over mu2 square, which is equal 37.2 over 4 square, which is equal 37.6 over 16 is 2.35, which is lesser than 3. Therefore, beta 2 is lesser than 3. The curve is platycortic. This is lesser than 3. It's a platycortic. So far, we have done about kurtosis as well measure of skewness based on moments as well as comparison coefficient of kurtosis, skewness, Boole's coefficient of skewness. Like we have done, please subscribe our YouTube channel.